Okay, our next point is if A is a square matrix. If A is a square matrix, then the condition is det A is equals to det A transpose. Okay, for if A is a square matrix, then det A is equals to det A transpose. If we determine what it is det of A, then if we do A inverse and do det, then the both of the values should be same, then it is called a square matrix, or the condition for a square matrix is det A is equals to det A transpose. Okay, Nana. This is our next point. Now we will jump to another point, which is if AB is equals to I and that equals to BA. Okay, AB is equals to I and I is also equals to BA, then the condition is A and B are called inverses of each other. What they are called? Inverses of each other. Okay, if AB is equals to I and BA is also equals to I, then AB are called inverses of each other. Okay, this is the most important point. This is asked in previous JEE mains also. So don't forget to see this point before going to examinations or revisions. Okay, our next formula is A inverse whole inverse is equals to A. Okay, what is that? A inverse whole inverse is equals to A, and AB whole inverse is equals to B inverse A inverse. What is that? A inverse whole inverse is equals to A, and AB whole inverse is B inverse into A inverse. These are the most important formula. Next also, our next formula is if A and A transpose are invertible, then A transpose whole inverse is equals to A inverse whole transpose. If A and A transpose are invertible, then the condition is A transpose whole inverse is equals to A inverse whole transpose. If A and A transpose are invertible, then A transpose whole inverse is equals to A inverse whole transpose. In JEE mains or any competitive exams or any common entrance test, they will ask that is if A and A transpose whole inverse is equals to A inverse whole transpose, then what is the condition for A? What is the relation between A and A transpose? The options will be invertible or vertible or solutions that they may ask in this way or both of none of the above. They may ask in this form. You can just click on invertible. Okay, A and A transpose are invertible, then A transpose whole inverse is equals to A inverse whole transpose. This way you can write the formula. This way these points are very useful to you. You just take a copy and note down these formulas, because these are going to rock our matrices chapter in a very important way. Okay, if you have to crack matrices for Z mains, this video is a very highlight. Okay, very highlight. So don't forget, if you want any information, any important topic, just pin in the comment section. Okay, next we will jump to our next important point, which is A is a non-singular matrix if A is a non-singular matrix. If A is a non-singular matrix of order 3 by 3. If A is a non-singular matrix of order 3 by 3, then A is invertible. If A is a non-singular matrix of order 3 by 3, then A is what? Invertible. Okay. A is a non-singular matrix of order 3 by 3, then A is invertible. Then the condition is A inverse is equals to HA by det A. What is that? If A is a non-singular matrix of order 3 by 3 and A is invertible, then A inverse is equals to RGA by det A. This is also a most important condition. I have picked up the most important conditions for you, Nana. So if you like the video, don't forget to like, share and subscribe. It will encourage me to do more videos, Nana. Okay, now we will jump to another important point. If A is equals to A, B, C, D. Okay, if A is equals to matrix 2 by 2, A, B, C, D, then A inverse is equals to 1 by AD minus BC into D minus B minus C A. If AD is minus BC is not equals to 0. Okay, if they in the exam they ask they had given A matrix and they ask A inverse form of this A matrix, then you have to do lot GA by det. You have to find out. It's a big deal. It's a very big deal. So you can't do. You can make this simpler by doing this. First we have to do AD minus BC. If it is equals to 0, then you can't follow this. No, you can't follow. There is also a trick to find this. You can pin me in the comment section. I will make that video also. If AD minus BC is not equals to 0, then you can do this condition AD minus BC and D minus V minus C. These are not just, these are the cofactors, okay? Just the cofactors of this, Nana. Okay, here minus signs, that's it. This is the A inverse. If these conditions are possible, if AD minus BC is not equals to 0. Okay, next point is A inverse whole inverse is equals to A. We had already discussed this point here also, Nana. Now we are discussing this point here also, so that doing twice will remember you a lot. Okay, next, A transpose whole inverse is equals to A inverse whole transpose. We are just a small revision. Here we had done this. Now we are doing this again. Next, for A, B, C whole inverse, C inverse, B inverse, A inverse is the formula. What is that? A, B, C whole inverse, C inverse, B inverse, A inverse. For just common entrance test, they will ask you up to here only. But for Z mains level, they will ask you 3 terms also. So don't forget to practice this formula. Next, we'll jump to another formula. Okay, Nana. Now we will continue. Next point is, if A is a n by n by n means n is any integer. Okay, you can keep anything real number. So if A is a n by n non-singular matrix, what is that? Non-singular matrix. Okay, if n A is a non-singular n by n matrix, then there are few conditions. If n by n matrix is a non-singular matrix, those are, first one is A into adj A into argument of A is equals to mod A into I. What is that first condition? A into adj A is equals to mod A into I. Now our second condition is adj A is equals to mod A into A inverse. Adj A is equals to mod A into A inverse. Okay. Just remember, if I by A is there, you can simply write A inverse. This will also help you in many times. So here see, we can back this to I by A. So we get A inverse. That's it. Now our next condition is edge A whole inverse is equals to edge of A inverse. What is that condition? Edge A whole inverse is equals to edge A into A inverse. Now our fourth condition, if n by n is a non-singular matrix, then edge A transpose is equals to edge A whole transpose. Okay, edge A whole inverse is equals to edge of A inverse, and edge A transpose is equals to edge A whole transpose. Next, our next condition is det of A inverse is equals to det A whole inverse. Det of A inverse is equals to det A whole inverse. Now our sixth condition is mod of edge A is equals to mod A in power n minus 1. Edge A mod of edge A is equals to mod A whole to the power of n minus 1. Next, our seventh condition is mod of edge A is equals to mod A to the power of n minus 1 whole square. Edge A into edge A, there is a mod. Edge of edge A, we have to read this, then that equals to mod A whole to the power of n minus 1 whole square. Next, the eighth point is edge of KA. K be any number or any constant, okay? That equals to K to the power of n minus 1 edge A. Edge A. Edge of K is equals to K to the power of n minus 1 edge A. Here what is K? Scalar. It is a scalar, Nana. Next, these are the conditions. You have to remember these conditions. These are very much important for your boards also, and also for Z mains. In Z mains, these formulas matter a lot, students. So don't forget to watch these formulas because these are very important for common entrance tests also. So next we will jump to another point. Okay, these are the conditions for n by n non-singular matrix. Next, the important point is if A and B are two non-singular matrices. If A and B are non-singular matrices. What is that? If A and B are non-singular matrices of same type, then the conditions, there are two conditions if A and B are two non-singular matrices, that is edge of AB is equals to edge B into edge A. Edge AB is equals to edge B into edge A. Next, the second important condition is mod of edge AB is equals to mod of edge A into mod of edge B. Edge of AB is equals to edge A in mod of edge A into mod of edge B, which is also equals to mod of edge B into mod of edge A. So these are the two important conditions if A and B are two non-singular matrices. Okay, next we will jump to another important point. Okay, to determine a rank and solution, first convert matrix into echelon form. Okay, echelon form means we will write if there is a matrix A, B, C, D, E, F, G, H, I, we have to convert in the form of AX, that is A, B, C, okay, D, E, F, G, H, I, X1, X2, X3 form. Okay, this is called AX form. Then we can find the rank in a very easy way. Excellent forms means just you have to just not do this form. You have to convert it into A, B, C, 0, 0, 0, E, F, I. Here there should be 0, then it is called what? Echelon form. Okay, next. This is number of non-zero rows is equals to rank of a matrix. What is the point? Number of non-zero rows. Number of non-zero rows is equals to rank of a matrix. Sorry, rank of a matrix. Okay, these matters a lot. Then, so our another important point is, if the system of equation Ax is equals to B is consistent if the coefficient matrix A and the argument matrix K are of same rank. Okay, this condition is not much important, but let's do. Okay, there is a system Ax is equals to B is a consistent. What is consistent, what is inconsistent? If you want a peculiar video, just put in the comment section, pin in the comment section, I will make for you. If the coefficient matrix A and the argument matrix K are same rank, this condition satisfies if coefficient of a matrix A and argument of a matrix K have the same rank. Ax is equals to B is a consistent if quotient of matrix A and argument of matrix K are in the same rank. Okay, next we will jump to our another point. Let Ax is equals to B is a system of equation m unknowns. Then the rank of the quotient R1 and rank of the argument matrix R2. Here Ax plus B is the system we are considering. And R1 is the coefficient matrix and R2 is the rank. This is the rank of coefficient matrix and this is the rank of argument matrix. This is the rank of coefficient matrix and this is the rank of argument matrix. Then if R1 is not equals to R2, what is that? Quotient, rank of coefficient matrix is not equals to rank of argument matrix, then Ax plus Ax is equals to B is inconsistent. What is that? Inconsistent and has no solutions. No solutions. R1 is not equals to R2, then in X equals to B is inconsistent and has no solutions. Next, another one is R1 is equals to R2, then that equals to N. Here what is N? Here N is any unknown elements are called N. Okay, R1 is equals to R2, that equals to N, then it is called as consistent. These have a unique solution. What is that? Unique solution. If it is inconsistent, it has no solutions. If there is consistent, it has at least one solution. Okay. Next, another condition is R1 equals to R2, but it is less than small n. What is your small n? Unknown elements. Then the condition will become, then the condition Ax is equals to B become consistent and has infinite solutions. Infinite solutions. Okay, these are the most important formulas in matrices. If you want any chapter important formula, just put me in the comment section and next video I am going to make the important formulas for permutations and combinations and many more chapters. So don't forget to subscribe and click the bell icon which is quite beside of it, and don't forget to like the video. Okay, bye bye.